No, sir.
Okay, no doubt. Okay, so let's start. We were studying basically acidity of alcohols. So, and we also did the resonance of phenol. I just want to give you a question, which is very easy. Wait a minute. This is our phenol, and I'm going to put NO2 at para position and another phenol, and I'm going to put NO2 at meta position. So there is a question. This is A and this is B. We need to tell about the acidity of alcohol, whether A is more acidic than B, A is less acidic than B, A is equal to B, and none of this. Which one of the option is correct for acidity in this? Please let me know if you have no idea about it. So basically in class 11, you have studied a chapter that is known as GOC, General Organic Chemistry. Sneha, please do respond. Nafisa,
A is greater than B.
why? Can you tell me why? Why A is greater than B? Why paranitrophenol is more acidic than metanitrophenol? Do you know the reason or you just
Sir, because
yes,
because it's more stable.
it is more stable. Why it is more stable? Why it is
Um,
less stable?
because
See, there is
because
we are not going to talk about stability here. See, if you have done the resonating structure of phenol, you might have noticed that the negative charge is on ortho position, is on para position, and then again on ortho. The negative charge was not on meta position. Can you see it? Can you see it? The negative
yes,
charge
sir.
on ortho, the negative charge on para, the negative charge on again para, not on meta. Is there any negative charge on meta? Is there any negative charge on meta?
No, sir.
Basically, at meta position, resonance is not affected, or you can see at meta position, this NO2 only have one effect, that is minus I. But at para position and ortho position, this NO2 has minus I plus minus R plus minus R. That means basically at para and ortho position, this NO2 has two power, that is basically minus I as well as minus R. Minus I as well as minus R. Are you getting my point? That's why it is more
Yes, sir.
acidic. It is more acidic than metanitrophenol. And another concept that you should know, or you already know, that resonance effect is more effective than inductive effect. So basically, this resonance is we give priority to resonance than inductive effect. If you got a situation in which a resonance is there and inductive effect is there, so we are gonna choose resonance. Is that clear, Sneha?
Yes, sir.
So first of all, I want to say, Sneha, that every day I will be giving a feedback to every student. So I want all of you to speak up. That will be more convenient for me. So I'm going to slide it down. Now the next concept comes, that is esterification. That is esterification. So here we have with esterification. Wait a minute. So write a topic, that is esterification. And I think you have studied this esterification in class 10th, carbon and its compound. And it's a very interesting topic, interesting topic. And in class 10th, you have studied that when alcohol, basically we took ethanol there in class 10th and ethanoic acid, and then we reacted, then we got a compound that is known as ester, and this process is known as esterification. This process is known as esterification, and with ester we also get H2O, that is water. So what is esterification? Write with me. Alcohols and phenols react with carboxylic acid and acid anhydride. Wait a minute. Alcohols and phenols react with carboxylic acid, comma, acid chloride, and acid anhydride and acid anhydride to form or to give esters. So it's very simple. In class 10th only we have studied that alcohols react with carboxylic acid and then we get ester. That process is known as esterification. Since we are in class 12, now we have to study about that, whether it is alcohol, and now we know what is phenol. So when alcohol or phenol or alcohol and phenol reacts with either carboxylic acid and either acid chlorides and either acid anhydride, we will get ester. This is very simple. So AR, that means benzene or arenes, or R attached with OH. If it is OH is attached directly to AR, arene, that is phenol, and OH is attached to R, that is alkyl group, then it is alcohol. If it is reacting with carboxylic acid, RC, R dash COH, in the presence of acid, this reaction is reversible reaction. This reaction is a reversible reaction. Then we will get ROCOR dash, that is ester, along with H2. So this is for alcohol or phenol reacting with carboxylic acid. And if we have alcohol or phenol reacting with acid anhydride, that means R dash. It's very simple. R dash CO whole twice O reacting in the presence of H plus. That is also a reversible reaction. Then we will again gain the same product. That means basically this ester along with carboxylic acid, And if you are going to react ArRCOOH, sorry, OH, alcohol, reacting with acid chloride, that means basically R dash COCl, in the presence of pyridine, then we will get R AR or AR or R, you can write it OCO R dash along with HCl. So all are basically reacting with carboxylic acid and acid anhydride and acid chloride, then we will get esters. Please write it. Please do write it and let me know if you have any doubt.
Yes, sir, finish.
Very good. So this is very simple. Do you know what is acid chloride? Acid chloride is also a functional group that is denoted with this RC double bond O. This is basically RC double bond O X. So this is basically acid chloride. Now there is an important reaction to make a basically a compound which is very famous, that is known as basically aspirin. The common name is basically aspirin. And now I'm going to show you the reaction which is very important. There is a compound which is, you can see, this is the compound, that is carboxylic acid here and OH. With respect to COOH, it is at ortho position. And if you are going to react this with acid anhydride, this is acid anhydride in the presence of H plus. Now, what we just learned is that acid anhydride react with alcohol or phenol to give ester. I didn't tell you that this acid anhydride react with carboxylic acid. So with the information I have given you, what you need to do, just react this acid anhydride with this alcoholic part and you will get OH and you will get an ester there, and the product will be COOH will be as it is, because this will not react with this. COOH is as it is, and this part will react with this OH, and you will get a functional group, that is COCH3. OCOCH3, that means that this compound is basically functional group. Which functional group it is? It is ester. Along with, you know that you just studied that when acid anhydride react with alcohol or phenol, it will give ester along with HCl. So there will be, oh wait a minute, not HCl. With ester you will get carboxylic acid. So you will also get a carboxylic acid with this CH. So the byproduct will be CH3 COOH. Please write it. And now you know this compound common name, which is very famous, aspirin. This is aspirin. It's common name. Acetyl. Wait a minute. Acetyl salicylic acid. It's also common. Acetyl salicylic acid. Please do write it.
Yes, sir, finished.
Very good. Sneha, you're not responding at all. Okay. Thank you. Moving to the next part, which is, so here are the chemical reaction involving OH cleavage is completed. Now, this type of reaction is basically reactions involving cleavage of carbon oxygen bond. That means basically CO bond in alcohols. So write topic, the second type of chemical reaction. My net is a bit slow, so it gets stuck in between. Okay. So Sneha, you have done the previous slide, right? So write a topic. We just completed the cleavage chemical reaction involving the breaking or cleavage of bond OH bond. Now we are going to study about the breaking or cleavage of carbon oxygen bond. So here the first reaction is reaction, that means alcohol reaction with hydrogen halides, that we already studied in the previous chapter, preparation of haloalkanes from alcohols. There we have already studied, but still you can see, if you have alcohol ROH and you have hydrogen halide, that is HX. So what happens here? It's very easy to understand. This bond will be broken, this bond will be broken, and R will be going with R will be going with X, and H will be going with OH, then it will make H2. So this reaction is very important. You can understand, like X is more negative, that's why delta negative charge. Hydrogen will have positive charge, oxygen delta negative or delta positive. Just add positive negative, and you will get your product. Now this reaction requires a reagent that is known as basically Lucas reagent, which is very famous and very important. Lucas reagent, and Lucas reagent is basically concentrated HCl plus ZnCl2. So if you are going to react alcohol with hydrogen halide in the presence of concentrated hydrochloric acid and ZnCl2, then you will get haloalkane along with water. Is that clear?
Yes, sir.
So please write it. So basically this Lucas reagent can be also called, wait a minute, just focus here, Lucas test. So basically with this test, we come to know about what type of degree of this alcohol is. If the reaction is very fast, very fast, that means it is tertiary. If it is slightly slow, that means it is secondary, and if it is very slow, that means it is primary alcohol. So there will be formation of turbidity, and in terms of turbidity, we can know about the degree of alcohol. So first you are going to write it. In case of tertiary alcohols, turbidity, cloudy solution, basically. Turbidity, turbidity of turbidity is produced immediately. That means within a few seconds, you will get a turbidity solution, cloudy solution in tertiary. In case of secondary alcohol, turbidity is produced after few minutes. After few minutes. Then for primary, you are going to write it on your own. In case of primary alcohol, turbidity is produced after hours. After 1 hour, 2 hour, or few hours, you can write. Please do write.
Yes, sir. Finish.
Nafisa, I have a question from both of you. Do you solve the assignment that goes on portal?
So, no, sir.
Why so? Sorry. Both of you don't solve the questions from portal. Why it is so? Can you give me a proper explanation or the reason? Don't you get enough time to solve the assignment? Midterm is going on. Okay, but still, midterm will be coming and going. Only your annual report will be staying with you forever, right? Nafisa, I am asking something. You haven't solved any assignment till date, or you solved some of it?
Sir, I haven't solved any.
You haven't solved any. That's wonderful. Very good. What about you, Sneha? Please do respond in chat. No, sir. Oh. So when did your no, when will be your midterm completed, Sneha? Please talk to me. And Nafisa, what's your next step? 16. Still, you have 16 days. I will recommend to in assignment you have only 4 to 5 questions. We don't give so many questions that you you don't have any excuses. You should not have. It will end on 16. Nafisa, so are you going to solve it from today or not?
Yes, sir.
So basically, I'm requesting both of you to solve as soon as possible whatever assignment is on portal, and please do send me in the group because I want to check. What's your aim after class 12? Are you going to do MBBS or are you going to do bachelor in bio or anything? Please let me know, Nafisa and Sneha.
Sir, I'm going to Indonesia.
You are going to?
Sir, I'm going to my home country, Indonesia, and I'm going to go college there.
Okay. So basically Indonesia. So what is what we call it? What will you be doing there? Like in study, MBBS or in college you have something
Yes, sir.
in your mind?
My parents wanted me to just go for literature, so yeah.
Okay, okay, got it. Okay, that's good. That's really good. And Sneha, you are going for forensics. That requires your chemistry should be very good for your forensics, right, Sneha? So basically, all I want to say is that please keep a study hard, and if you are getting a good marks in class 12, and if you will have a very good knowledge, then you will get in. Everyone does forensics, whoever wishes to do. But if you are going to do it from a very reputed university or college, that will be a very, very good impact on your life. Are you getting my point? Nafisa and Sneha. Okay.
Yes, sir.
So let's start dehydration. The next chemical properties is dehydration, and I think you know what does this dehydration means. Basically, removal of water or elimination of H2O. That is called dehydration. So basically, I am going to write a point. Alcohols undergo dehydration. That means removal of a molecule of water. To form alkenes. So basically, how we are going to remove water from alcohol? So basically, we are going to treat on treating alcohol with a protic acid, that means basically the one which gives H plus, protic acid. As for example, we can take H2SO4, concentrated H2SO4, or H3PO4, phosphoric acid, and catalyst, and you are going to heat it. Catalysts such as anhydrous zinc chloride or alumina, Al2O3, alumina. Then you will get alkene from alcohol. You need to heat it. So first write it, then I am going to show you.
Yes, we're finished.
So see, basically, if you have alcohol like this, if you have, wait a minute. If you have alcohol, this is hydrogen, this is off. Again, it's disturbing. This is OH, and this is like this. And if you are going to mix this with the H plus, that means protic acid, and heat it, what will happen? This will be eliminated. H and OH, that will be H2O, and you will get an alcohol. So basically, in this process, you will be getting a carbocation, and you know that which carbocation is more stable, tertiary, then secondary, then primary. So for primary is since very less stable among secondary, tertiary. Primary will have some drastic condition as compared to secondary and tertiary. And tertiary is on very low condition, then you will easily get. In tertiary, you will easily get alkene. In secondary, you will have to give it a very high temperature, and in primary, very high temperature. Very high temperature. Please do write it.
Yes, we're finished.
Sneha, are you done with this? Now see, we have, just let me know the product, the name of the product. If I'm going to react C2H5 OH with concentrated H2SO4, then at 443 Kelvin, and if you have secondary alcohol like CH3CH OH and then CH3, then you will see the condition is lower than the primary. This is 85% H3PO4, and the temperature is basically 440 Kelvin. And if you have tertiary alcohol, that means CH3C, and then we have CH3 above, top, and bottom as well, and then OH here. then the condition is very low as compared to primary. Only 20% H3PO4 we require H3PO4, and the temperature you can see is very low because 3 degree alcohol, 2 degree. This is the reactivity order. Since 3 degree carbocation is very stable, that's why. So please write the name of the product. So basically in 3 degree, 2 degree, milder condition, milder condition. Let me know when you are done with this. If you have any doubt in this, you can ask me.
Sir, the first one will be CH2 double bond CH2, and the
What is
second
the
one
name?
will be CH3
CH3.
CH3 CH double bond CH3.
CH2, not CH3. If you are going to make it 3,
CH2.
then carbon will have 5 bond, which cannot
Yes, sir.
be possible. So can you name it? Instead of telling me the molecular formula like CH2 double bond CH2, you should tell me the name. That will improve your IUPAC also.
Ethene. Ethene.
Ethane. It is ethane. Can you tell me the name of the second one?
Propene.
Propanene or propene. Very good. What about the third one? Please do it.
So the third one is butene.
Is it butene? So what you just did, it's very simple. You are going to remove OH from here, and you can remove hydrogen from here, here, and here, wherever you wish. But you will not get different product. If you are going to make different product and you are going to name the write the IUPAC name, you will get the same name. That means same product you will get. So the product will be, I'm going to write CH2. I just removed hydrogen from here. So I just removed, it was CH3, now it will be CH2, and double bond between this carbon and you will get CH3 and CH3 here. So if I'm going to write the name of the it, so 1, 2, 3. So the name will not be butene, the name will be basically 2-methyl prop 1-ene or propene. Are you getting my point? Tell me.
Yes, sir. Yes,
And
sir.
you will be getting as a byproduct water. You will be getting water as a byproduct. You will be getting water as a byproduct. Is that clear?
Yes, sir.
So please write it. Sneha, you didn't respond at all.
Yes, sir. Finish.
Very good. Sneha, please do respond so that I will be changing the slide. Thank you. Very good. Now I am going to write a point about it, which is very easy. We can say the reactivity. I already wrote it on the right hand side of the previous slide, but still I am going to write the relative ease of dehydration. The relative ease of dehydration of alcohols follows the order. Follows the order. As you know, what is the order? So the order is basically tertiary, then secondary, and then primary. Sneha, do you speak Hindi? Sneha, not Sneha, sorry. Sneha, no, sir. Okay. Nafisa, what about you? I was
No,
just
sir.
asking because I think uh, in the past lectures in different batch there are I was just speaking. That's why I was just asked. Are you done with this? Sneha, where are you from? Okay. Okay. Thank you. Okay. Okay. Got it. Okay. Can I change the slide?
Yes, sir.
Okay. Now see, Now we are going to learn about the mechanism, which is very important. Mechanism. And in this, the mechanism has 3 steps, which is very easy to understand. So for mechanism, I'm going stepwise. So in step 1, there will be formation of protonated alcohol. First, we are going to make a formation of protonated alcohol. In order to make an alcohol, protonated alcohol, what you need to do is very simple. You just need to react that alcohol with acid H plus. So we have, I'm going to take ethanol. And I'm going to write it ethanol as this. So you know, this is H, and you also know that this is OH, in which oxygen will have 2 lone pairs. And if you are going to react this with H plus, that means proton. So what will happen? Oxygen has more electron rich, so it will attack here, and then we will get hydrogen, carbon, hydrogen. The left carbon will be as it is, and the right carbon you can see hydrogen, and you can see, since oxygen donated 1 electron to H plus and made bond with it, so oxygen will have negative charge. So this will be the step 1. In a step 2, there will be formation of carbocation. So I'm going to write it, formation of carbocation. And how the formation will take place, formation of carbocation will take place. So basically, first step is the first point, it is the slowest step. It is the slowest step, and hence the step which is slow is slowest. So basically that step is the rate determining step, and hence the rate determining step. So first of all, you are going to write up to this, then I will explain.
Yes, sir, finish.
Very good. Sneha? Very good, both of you. So in the first step, we did react alcohol with proton, then we prepared protonated alcohol. Now, this protonated alcohol is very less stable, very unstable. Why? Because you can see oxygen has positive charge on it, and whenever there will be positive charge on oxygen, it is very unstable. So in order to stabilize itself, what will oxygen do? It will take electron from carbon and it will stabilize itself. How it is going to stabilize itself? It will take electron from carbon and it will become H2O, eliminated. Now, since carbon is donated, the right carbon is donated one of its electron to oxygen. So what it will have? It will have positive charge, and this is how the formation of carbocation took place. And this step is basically slowest step. That's why it is rate determining step. Is that clear? Please write this.
Yes, sir.
Rate determining. Very good. Sneha, very good. Now the next step comes, step 3, which is also very easy to understand. Step 3. So we are going for step 3, and here alkene forms. And how alkene forms? So basically, in the first step, you have seen that we reacted alcohol with proton, and in the last step, we will eliminate this proton. So basically, in the last step, formation of ethene by elimination of a proton. By elimination of a proton, we are going to eliminate the proton. So you can see in the product in the second step will be the reactant in the third step. So you can easily understand this. It's very easy. So what will happen? This will be like this. This hydrogen will give one electron to carbon and it will make bond with the next carbon, and there will be double bond formed. And the questions many times have been asked, write the mechanism of the formation of ethene from ethanol. So these are the steps you have to follow for your 3 marks, and H plus will be eliminated. Is that clear? So the proton we used in the first step will be eliminated in the last step. Please do let me know the product. Please do let me know when you are done with this.
Yes, sir, finish.
Very good. Now see, I'm going to give you a question. You are going to treat this with H2SO4 and heat. Write all the products possible, right? All the products possible. And also, and which one is major product?
Sir,
Yes.
The the products would be butane one all and butane two all.
These are the product you got, right? Now, can you tell me which one is more stable? Butane one all and butane two all. Do you know this is alcohol? And if I am going to react with H2SO4 and uh, heat, I'm going to heat it. Then will it be alcohol? This is already alcohol, and we are going to heat it. That means dehydration will take place, and alkene will form, right? Nafisa?
Sir, but the reaction before was like that. It just became.
Yes.
Oh, right. Double bond.
Yes. Should
So
I slide it up?
butene,
Yes. Butene and
butene, and butene.
butane. Okay. Just let me check. So what you just did, it's very simple. This OH is connected with this carbon, and with this carbon, there is directly connection of two carbon attachment, this and this. If you are going to remove hydrogen from here, the double bond will be formed between this carbon and this carbon, this. And if you are going to remove hydrogen from this carbon, the double bond will be formed between this and this. So it will be like this. So this is one in butene, and this is butene. So can you tell me which one is major product? Can you tell me
Butene.
why butene? Whenever you don't have any idea about stability, see the for stability. What symmetry? See the symmetry. In which symmetry is more? Can you tell
All
me?
right, sir. Yeah.
Yeah.
The second
So the
one, the
first point
symmetry.
is this is the measure product. Now the question is that is there any way to predict the stability of alkene? Yes, there is a way. So for this type of question, carbocation, carbon anion, free radical, alkene, and functional group, there is a term that is alpha hydrogen, and stability is directly proportional to alpha hydrogen. So how we are going to find alpha hydrogen? Directly proportional to this is alpha. This is basically alpha hydrogen. How we are going to find alpha hydrogen? See how we are going to find alpha hydrogen. With respect to this alkane, we have two alpha carbon. This is alpha carbon and this is alpha carbon. And the hydrogen which is connected with alpha carbon are called alpha hydrogen. So you can see in this molecule, you have two alpha carbon, and with that two alpha carbon, we have total of 6 alpha hydrogen. But in this butane, you can see this is the butane. So this alkene is basically directly connected to only one carbon. That's why it has only one carbon, and this carbon has two hydrogen. That's why this alkene or this molecule have two alpha hydrogen. So the one which has more alpha hydrogen is more stable than the one which has lesser alpha hydrogen. Is that clear? This all stability, acidity,
Yes, sir.
basicity, these all we have studied it in class 11. Okay. So please write it and let me know when you are
Yes,
done
sir.
with this.
Finish.
Sneha, are you done with this? Sneha, please do respond. Okay. Now the next topic comes. Next chemical reaction involving CO cleavage, CO bond cleavage. That is basically oxidation. Now we are going to learn how to oxidize this alcohol. How we are going to oxidize this alcohol. So basically, what is oxidation? So I'm going to write a point right with me. Oxidation of alcohols involves the formation of carbon oxide double bond with cleavage of an OH and CH bond. So see, first you are going to focus there, and then you are going to write it. It's very easy. If you have any alcohol is like this, and there is hydrogen. So in order to oxidize this alcohol, what you need to do, this OH bond will be broken. That means H will be eliminated, and a hydrogen will be connected to this carbon. See what is the concept here, which is very easy and very important questions comes on this topic. So see, this carbon is connected with OH, and this carbon must have hydrogen. If there will be no hydrogen with this carbon, so there will be no oxidation, there will be cleavage of bond. So now you see this OH, that means this hydrogen will be eliminated, and this hydrogen will also be eliminated. Now this carbon will have two bond left, and you can see oxygen, one bond. Now neither of oxygen and carbon is satisfied because it doesn't have 8 electrons in the outermost shell, so they make double bond with each other, and in this way alcohols oxidize. So it's very simple to oxidize alcohol. Alcohol oxidize either into ketone or either into aldehyde. If you are going to oxidation, first of all, what is oxidation? Oxidation is basically addition of oxygen or removal of hydrogen. So it's very simple to understand. If you are going to oxidize an alcohol, either it will be oxidized into ketone or aldehyde. But if you are going to take a very strong oxidizing agent, which will act as a reagent, if you are going to take a very strong oxidizing agent, what will happen? The alcohol will be directly oxidized into carboxylic acid. And if you are going to use a mild oxidizing agent, that will convert into either aldehyde or ketone, depending upon the type of alcohol. If it is primary, then it will be converted into aldehyde. If it is secondary, then it will be converted into ketone. If it is tertiary, then it will not be oxidized because this carbon will not have any hydrogen. So that's why tertiary alcohol cannot be oxidized. So see, my point is that if you have primary alcohol, it will be converted into aldehyde. If you have secondary alcohol, it will be converted into ketone. You will see the example. See, I'm going to explain it again. First write it, then I'll be going to take an example.
Yes, you finished.
Finished? Sneha? Now see, it's very easy. If you have this RCH2OH, that means, can you tell me whether it is primary, secondary, or tertiary?
Primary.
It is primary. So it will be directly converted into RCHO. And again, if you are going to convert it, oxidize it, it will be converted into carboxylic acid. How does this happen? It's very easy to understand. You can see this carbon has 2 hydrogen and this OH. Can I write this? What was the concept of oxidation of alcohol? This will be broken or cleaved. H will be eliminated, and with this carbon, one hydrogen should be there, must be there, and it will be eliminated. So it will be forming RC, and you can see there is one hydrogen left. So I am going to write it here, and you can see oxygen. It should be double bonded. Is that clear? So primary alcohol into aldehyde, if you have the reagent is milder aldehyde, and if you are going to again oxidize it, if you are going to oxidize this aldehyde, what will happen? It's very simple to understand. One oxygen will be added here and you will get RC double bond O OH. So basically what is oxidation? Oxidation is either a removal of hydrogen or addition of oxygen. So in the first step, removal of hydrogen took place, and in the second step, addition of oxygen took place. In this way, a primary alcohol can be converted into aldehyde and then carboxylic acid if your reagent is mild oxidizing agent. And if you are going to use a strong oxidizing agent, the alcohol will be directly converted into carboxylic acid. Please do write it.
Yes, sir. Finished.
Very good. Sneha, please do let me know. Very good. Now see, I'm going to write a point. Please write with me. A strong oxidizing agent that I was talking about, a strong oxidizing agents such as acidified potassium permanganate, acidified potassium permanganate, that means basically KMnO4 in the presence of H plus, are used for getting carboxylic acid from alcohols directly. It's very simple. Please do write. Very good. Thank you. Thank you, Sneha. Now, there is another point which is very important. CrO3 in anhydrous chromic trioxide, chromium trioxide, you can say, anhydrous medium is used as oxidizing agent for the isolation of aldehyde. Basically, it is a mild oxidizing agent, isolation of aldehydes. So see what it is. If you are going to use RCH2OH, if you are going to use CrO3 anhydrous form in this will be converted into aldehyde. This CrO3 is basically mild oxidizing agent. There is another reagent that is known as PCC. That is basically pyridinium chlorochromate. Basically, it is a complex of, I'm going to write out about write about PCC. Complex of chromium trioxide. Chromium trioxide. This is X with pyridine and HCl. So basically, it's very simple to understand. You have a PCC, which is also a mild oxidizing agent. This is also a mild oxidizing agent. And if you are going to use PCC, which is pyridinium chlorochromate, which is a complex of chromium trioxide, then we can easily get aldehyde. So always remember that primary alcohols will be oxidized into aldehyde only, not ketone. For ketone, we should have secondary alcohol. Please
Yes,
do
we
let me
can.
know. Very good. It's very simple to understand. CH3, CH, double bond, CH. This is CH2, OH. And this is PCC. So what I just taught you, just don't focus here. What I taught you is this: in the presence of PCC, a primary alcohol will be oxidized into aldehyde. So the rest part will be as it is. The rest part will be as it is. And you can see this will be CH. What happens here? How can I write CHO at the place of CH2H? It's very simple to understand. You can see this is H, this is H. And before that, before this, basically all the part will be same. This is CH, this is CH, this is double bond, this is double bond, and then this is. So in oxidation, what I taught you is very simple. Just remove hydrogen from oxygen and remove carbon from this carbon, remove hydrogen from this carbon to which OH is connected, not with this carbon, this carbon. You are not going to remove the second hydrogen after the hydrogen of oxygen. You are not going to remove from here. You need to remove from here, and you will see this will be written as CH3CH double bond and then CH, and then C and hydrogen is removed. That means hydrogen, and then there will be double bond between oxygen and carbon. So this PCC is basically a mild oxidizing agent. So please write it.
Yes, we finish.
Very good. Now see. Sneha, are you also done? Sneha, please do respond. Thank you. Sneha, your mic does not work, or you don't want to speak. Secondary alcohols are oxidized to ketone, as I told you, by chromic anhydride. That means CrO3. So you can see, if you have secondary alcohol like this and you are going to use CrO3, then what will happen? Nothing will happen. only ketone will be formed. Now see what is the concept behind it. The same concept from starting. You can see what I told you for the oxidation of alcohol. Remove hydrogen from oxygen and hydrogen from the carbon to which O is connected. So there will be this, and in order to satisfy, this will be like this. Okay. Okay, net is slow, so I might get disconnected. Okay, no problem. Just fix it. So this is how we are going to prepare ketone from secondary alcohols. If you are going to oxidize secondary alcohols, it will be converted into ketone. If you are going to oxidize primary alcohol, it will be converted into aldehyde. But if you are going to take tertiary alcohol, it cannot be oxidized, but first it will be broken into two parts.
Yes, sir, finish.
Sneha, you are also done with this? Now I'm going to write about the tertiary. Tertiary alcohols. Please do write with me. Do not undergo oxidation rates and if you are going to give a very drastic condition under strong reaction condition, such as oxidizing agents, KMnO4 and elevated temperatures. This is drastic condition. Then bond breaking will take place. Then cleavage of various CC bonds take place. And a mixture of carboxylic acid containing, since it is broken, so lesser number of carbon, containing lesser number of carbon atom is formed. It's very simple. First, it will be broken into multiple parts and there will be formation of carboxylic acid lesser than the number of carbon containing in parent. Please do write it. This is it for today. Thank you. Please write.
Yes, sir, finish.
Okay. Thank you, Sneha and Nafisa.
Thank you, sir.
Thank you. Sneha, are you done with this?